Hello and welcome to Lecture 4, Vectors. In this lecture, we're going to talk about what a vector is. We're going to learn how to decompose vectors and then how to add vectors together. So what is a vector?
Hey. I'm applying for a new villain loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh yeah!
So as Vector said, a vector is a quantity that has both a magnitude and a direction. We're going to start by stating the direction of the following vectors. Okay, so we can practice. There's multiple ways to state the direction of vectors. We're going to go through all of them now so that you're more familiar with them. So here you can see that we have a vector here that's pointing in this direction, going in the northeast direction. Okay, but it's not exactly northeast, because if we were to just say northeast, that would imply that it's exactly in between north and east with a 45-degree angle between the two. But here there's not a 45-degree angle between the two, so we can't just say northeast. Okay, so the way we can state the direction for this vector is we can say east, because that's where the reference position is taken from, east. So I'm going to write east. And then from east, we're going 30 degrees towards the north. So that's one way we can say the direction of this vector. Okay, we can do it a different way as well if we wanted to. I'll just change the color so it doesn't get too confusing. So we can also start with our reference position of north. So this is north over here. And so from north, we're going, what angle would that be? Well, this full angle here is 90 degrees, so if the bottom angle down here is 30, then this must be 60 degrees. So this is the same as saying north, 60 degrees towards the east line. So these are equivalent. It doesn't matter which one you use, they both mean the same thing. Okay, the first one is a little bit easier because the 30 degrees is already there for you. So you would say east, 30 degrees towards north, and that's how you would write it out. Now there's also another way you can say the same thing as well, and I want you to be familiar with all the different ways. So east 30 degrees north is the same as saying 30 degrees north of east. So we're 30 degrees north of the east line. Okay, likewise, for the second example, it would be the same thing as saying 60 degrees east of the north line. So all four of these answers would be acceptable. They're all correct. Okay, so you can write whichever way you're more comfortable with. Now that said, I can give you a direction in any of these fashions, and you should understand what they mean. So you should understand both options here, or all of these options, but whichever option you're more comfortable, that's what you can use as your answer. Okay, so let's do the next one. So the one way of saying this is we can say west, because this is west. And then from west, we're going 40 degrees towards the north. So 40 degrees north. Okay, or we could have also said 40 degrees north of west. It means the exact same thing. We're 40 degrees north of the west line. Okay, I'm just putting square brackets in here because this is how we'll write it out when we have a magnitude and a direction. Right now we're just looking at the direction. Again, we can think of this as going from a reference line of the north line. So this is the north line here, If the bottom angle here was 40 degrees, then this angle over here would have to be 50 degrees because together they add up to 90. So we could also say north and then 50 degrees towards the west line. North 50 degrees west. Or just like the other example, we could also say 50 degrees west of north. Okay, so all four of these are acceptable answers. All right, now let's move on to C and D, and notice that in C and D we don't have northeast, southwest anymore. We have X and Y axes. So here it's a little bit different. We're not going to say 15 degrees south of east or east 15 degrees south, because I didn't tell you that this is east over here and this is south. And if that wasn't told to you, you can't just assume it. So instead, we're going to say 15 degrees either above or below an axis. So this is 15 degrees below. And what axis is this? This is the positive x-axis. So that's our direction there. Okay, and that's the only way that we're going to answer that. 15 degrees below the positive x-axis. This is just a dash here, x-axis. Okay, let's do D. If you think you know how to do D, go ahead and do it. Pause the video and then continue to make sure you're correct. So here I have 45 degrees. It's below. And this time this is the negative x-axis. Right? This is the positive x-axis pointing to the right, negative x-axis points to the left. So I'm going to say 45 degrees below the negative x-axis. And that's it. All right, so there we've practiced how to name directions. So if you know the x and the y components of a vector, you can then find its magnitude and direction. So we're going to use Pythagorean Theorem to find the magnitude, and then we're going to use tan theta equals opposite over adjacent, which is the tangent ratio, to determine the direction. By convention, we typically assign positive values to components that are pointing to the right and upwards, and vectors that are pointing to the left and downward would therefore be negative. Okay. So let's start with number 2. State the magnitude and direction of a vector that has an x component of 32 and a y component of negative 14. So let's just draw out what this looks like first. So this is my y-axis. This is my x-axis. My x component is 32, so I'm just going to say that this is around 32. My y component is negative 14, so it's below the x-axis because it's negative. So I have a vector that has an x component of 32 and a y component of negative 14, so it looks something like this. Okay, so it goes to the right 32 and down 14. Okay, so we want to know what the magnitude and the direction of that is. So we can just make a triangle out of that. So let's say this is our triangle. And we know the x component of the triangle is 32. So that means the length along the x-axis. The y component is 14. It's negative 14, but the length of that is 14. It's just pointing downwards. So we can decompose our vector. It would look like this. A vector pointing to the right 32 and down 14. Now the magnitude is referring to the hypotenuse. This is the magnitude of the vector, is the hypotenuse over here. Okay, so I'll just call it, it's 32 newtons, so I'm going to call it force because N is a unit of force. So this is my force vector. When I'm looking for the magnitude of it, I'm going to use Pythagorean Theorem. So if you remember from before, Pythagorean theorem is a squared plus b squared equals c squared. Now when we're labeling our a, b, and c, the most important is that we know that c is always the hypotenuse. So our c is this hypotenuse over here. And the a and the b don't matter which one's which as long as it's not the hypotenuse. So I'll say this one's a and this one's b. So I'm going to start to fill in the numbers that we know. My a is 32, so I have 32 squared plus b squared. B is the negative 14, but I'm just going to write 14. Now it doesn't matter if you're going to write 14 or negative 14. If you're going to put a negative 14 here, it's very important that you put it in brackets and then square it, because then the answer becomes positive. If you don't want to bother doing that, just leave it as a positive value. We're really just looking at the length of this side of a triangle, so there's no such thing as a negative length. The negative just means it's pointing down. So I'm not going to put negatives in when I do this, but if you want to, it's fine. Just remember to put the brackets in. Equals c squared. So I'm going to type this onto my calculator. I have 32 squared plus 14 squared, or I could have negative 14 in brackets and then squared. And I have 1,220 equals c squared. I'm going to rewrite it so that my c squared is on the left side. And remember, when you're trying to get rid of a squared, you do the opposite, which is square rooting. I'm going to square root both sides, but remember to put a plus or minus in front. So when I take the square root, on the left side, the square root of c squared is just c. And on the right side, the square root of 1220 is 34.9. The number after the 9 on my calculator is a 2, so I'm not going to round the 34.9 up to 35.0. I'm going to leave it as 34.9 because the 2 is less than 5. All right, so now we know our C is 34.9. If we want to think about units, we have 32 newtons was the x component, negative 14 newtons was the y component, and now my hypotenuse would then be in newtons. Okay, now I labeled my C as F, so I really shouldn't have called it C all along. I should have been calling it an F here. So I'm just going to rewrite that as F instead. So I just solved for the force, which I labeled as an F. Now that's just the magnitude, which is the length. I also need to find the direction. The direction meaning, is it above the x-axis? Is it below the x-axis? Is it the positive x-axis or the negative? And what is the actual angle that it is above or below the x-axis? So what I need to find first before I can start is this angle here. And I'm going to label it as theta. Theta as my angle. Now I'm going to look for that angle theta, and to do that I'm going to use tan. So I'm going to say tan of my angle theta, which is what I'm looking for, is equal to opposite over adjacent. Okay, so I'm using SOHCAHTOA here. I could have used SO or CA instead, because I do know the hypotenuse now is 34.9, but that's a rounded value, whereas the 32 and the 14, those are exact values. So I'd rather use tan so that my answer is more precise. So I'm going to fill in the numbers I know. Tan of my angle that I'm looking for is equal to the opposite side. Again, I'm just going to use positive 14 over the adjacent side, 32. Now when I want to solve for theta, I want to bring the tan to the other side, and to do that, I write tan inverse of 14 over 32. I'm going to type this onto my calculator. I have tan inverse of 14 over 32, and I get 23.62. The 2 is smaller than 5, so I'm not going to round it up. I'm just going to write 23.6 instead of 23.7. And that's an angle in degrees. So now the magnitude of the vector is 34.9 newtons. And the direction would be 23.6 degrees. Now, is that above or below? It's below. And is that the positive x-axis or the negative x-axis? It's the positive x-axis. So I can put everything together if I like. Instead of just putting an F, I'm going to put an F with a vector on it. When there's no vector, that means I'm just finding the magnitude. I'm just finding the length of the vector. Now, because I have a vector on top of it, a little arrow, that means I have to write out the magnitude, 34.9 newtons, and the direction, 23.6 degrees below the positive x-axis. And that's it. So that's the answer to this question. State the magnitude and direction of a vector that has an x component of 32 newtons and a y component of negative 14 newtons. All right, let's move on to question 3. If you travel 35 meters north and then 18 meters west, what is your total displacement? Now, displacement is a vector, so it's asking for the vector itself, displacement, meaning it wants the magnitude and the direction. So it's just like question 2. So it wants the displacement given as a magnitude, which is the length of the hypotenuse, and the direction it's going into. Okay, so we'll start by just drawing a picture of what this looks like. So here's north. This way is west. I can put in all my directions if I want. North, east, south, west. Okay, so what did we do? We traveled 35 meters north. So we went north 35 meters. And then from there, we traveled west 18 meters. Okay, so it's not drawn to scale, but just to give you an idea, we went 35 north, 18 west. And now our displacement is the resultant of that. We're starting from the beginning of the first vector, and we're ending at the end of the last vector. So that would be right here. So this here is our displacement vector. Okay, so if we're looking for the magnitude of it, what do we use? We can use Pythagorean Theorem. Let's label everything that we know. Our D is our hypotenuse here, so that would be C. And then A and B can be any of the other two sides, A and B. So when we write out our formula for Pythagorean Theorem, we'll start with A squared plus B squared equals C squared. Now let's sub in what we know. A is the 18 meters, so I'm just going to write 18 squared, plus B is the 35 meters, so that's 35 squared, equals C squared. Well, C, we called it D for displacement, so I'm just going to say D squared. Okay, that's the variable I chose to use when I named that side. All right, so now I'm going to type this into my calculator. 18 squared plus 35 squared, and I get 1,549 is equal to D squared. I'm just going to rewrite it so my D is on the left side because it looks a little nicer. And then I'm going to square root both sides with a plus or minus. And I'm left with D is equal to, I'm just going to square root this answer here on my calculator. I get 39.35. So my 39.3, that 3 is going to be rounded up to a 4 because it's followed by a 5. Okay, if it's followed by a 5 or greater, it will get rounded up. All right, my units for that is meters because that's what the units were for the other two sides. So now we know the magnitude of the displacement, so the length of the hypotenuse. Next, we need to find out what the angle it is, or the direction it has. So I'm going to put in a little theta in this triangle, and the angle theta is always starting from the beginning of the displacement vector, so it would be down here. This is the angle that we're looking for. So just like before, we're going to use tan theta equals opposite over adjacent to find that angle. So I have tan of my missing angle theta is equal to the opposite side. So opposite of the theta is that 18 meters. So 18 over adjacent. The adjacent side is 35. And now to solve for theta, we need to bring the tan to the other side, and we do that using the tan inverse button. So now on my calculator, I'm going to type tan inverse of 18 over 35, and I get 27.21. I'm going to round it to just 27.2. That's an angle, so it's in degrees. Now my final answer, it asks what's my displacement. So my displacement is the same letter D, but I'm going to put a vector on top of it, a little arrow showing that I'm going to give both the magnitude, 39.4 meters, and the direction. So the direction this time, we're using northeast southwest because the question tells us that we went 35 meters north and then 18 meters west. So we're not going to do what we did in question 2 where we said above or below the x-axis, for example. We're going to use northeast southwest. So we're going to start with north because that's our reference line. North, and then from north we're going 27.2 degrees towards west. Right? We're going this way towards west. And that's our final answer. All right. Okay, so in question 2 and 3, we knew the x and the y components of our vectors, and we used them to figure out the magnitude and the direction of the resultant. The resultant just means the hypotenuse itself. Now we're going to do the opposite. We're going to decompose our vectors into perpendicular components, which is going to be useful for the next part of this lecture, where we add vectors to each other. So what we have here is we know the hypotenuse and we know the angle, and we're going to use that to find the x and the y components. So it's basically the opposite of what we did in question 2 and 3. All right, so I'm going to start by just drawing what this looks like. So I have a 7 Newton force acting on an object at an angle of 40 degrees above the positive x-axis. So let's draw our axes first. This is my x-axis. This is my y-axis. So this is my positive x-axis. This would have been my negative x-axis going to the left. Okay, just like downwards would have been my negative y-axis. So we're 40 degrees above the positive x-axis. So let's estimate 40 degrees. Halfway exactly would be 45. So we're just less than halfway to the y-axis. Here's my 40 degrees right here. And it's a 7 Newton force. So it's implying that the hypotenuse is 7 newtons. We want the horizontal and vertical components of the force, meaning we want the x and the y components. So here's my x component right here. I'll just call it x. And here's my y component, y. Notice I put vectors pointing to the right and up, and that's because the 7 Newton vector points to the right and up. See, it's on an angle, but the vector itself is going to the right and upwards. So when you decompose it into the x and y components, each of those vectors should be pointing to the right and upwards. Okay, so now we're going to solve for x and y. So we'll start off by labeling our 3 sides of our triangle. We know one side and we know our angle, so we're going to use SOHCAHTOA. So 40-degree angle, opposite of that is called the opposite side. Here's my 90-degree angle. We know it's 90 degree because the x and the y axis, those are perpendicular to each other. They're 90 degrees to each other. 90-degree angle always points towards the hypotenuse. And then we're left with the side that's adjacent or touching the 40-degree angle. That's not the hypotenuse. That would be this side here that we labeled x. So I'm just going to write out SOHCAHTOA. So we'll start off by looking for x. So we can see that x is the adjacent side, and we know the hypotenuse, the 7 newtons. So we're going to use the SO, CA, or TOA that has adjacent and hypotenuse in it. So that would be CA. So we're going to say cos of the angle is equal to adjacent over hypotenuse. All right, so what's the angle? The angle's 40 degrees equals adjacent, that's x, we labeled that as x, over hypotenuse, which is 7. Okay, so now we can turn both sides into a fraction. The right side's already a fraction, so we'll turn the left side into a fraction, and then we'll cross multiply. So we'll say x times 1, which is just x, is equal to 7 times cos 40, which is 7 cos 40. And now we can just type this onto our calculator. 7 cos 40, and we get 5.36. And the units for that, everything was in newtons, so that would be newtons. Okay, now we'll do something similar to find y. We're looking for y. Now, y we labeled as the opposite, and we know the hypotenuse, which was 7. We also know the adjacent, but the adjacent does have some rounding errors, so let's not use that one in our calculation. We have a choice, so let's use the hypotenuse instead. So opposite is what we're looking for, hypotenuse is what we know, so we would use SO. So now we have sine of our angle is equal to opposite over hypotenuse. So let's fill in what we know. Sine, our angle is 40 degrees, is equal to the opposite side, which we labeled as y, over the hypotenuse, which is 7. Again, we're going to make both sides into fractions since one side already is a fraction, and then we'll cross multiply to get rid of those fractions. So we'll multiply 1 times y, which is y, is equal to 7 sine 40. Now we can just type this onto our calculator. 7 sine 40, and we get 4.4995. I'll just write that out so you can see it all. 995. But let's say I want to round it to the nearest hundredth. I would round it, the 5 would round the 9, this 9 up, making this making it 5.00. Okay, so this 9 gets rounded up to a 10. This 9 gets rounded up, so that just makes the whole thing 5.00. Again, the units are newtons. Okay, so the question's asking for the horizontal and vertical components of the force. The horizontal components then is 5.36. And it's positive because it is pointing to the right. And the vertical component is 5.00. And it's also positive because it's pointing upwards. Okay? So make sure you understand how to do this question because we're going to use this concept to do the next questions, which are adding vectors. Okay, so this takes us to vector addition. So we can add 2 or more vectors. To do that, all we need to do is find the x and y components, or the horizontal and vertical components, and then add the components together. Okay, so I'll show you step by step how to do this. So we have 2 vectors, v1 and v2. They're bolded here. Bolding is the same as putting a vector hat on top. It's the same thing. Okay, I can put the vector hat. It just shows you that these vectors have a magnitude and they also have a direction. Okay, that's what the definition of a vector is. So we have two vectors, and what we want to do is add them together. So we're going to start by drawing what they look like, and then we're going to find the x and the y components of each of the vectors, and then we're going to add them up, and then we're going to draw what the resultant looks like and find the new magnitude and direction of that resultant. So it's quite a lot of steps. So we'll start by drawing each of these vectors. So for the first vector, notice that we're talking about east, 25 north, so I'm going to call this, this one would be north, east, south, west. Okay, so I have 8 newtons, east, 25 degrees north. So east, from east we're going 25 towards north. So we're not going halfway at all, we're just going less than that, 25. Okay, and its magnitude was 8 newtons. And the angle was 25 degrees. Okay, so that's the first vector. That's what that one looks like. And the second vector, if I redraw, so this one, it goes 2.5 newtons west, 15 degrees towards south. So we're going to go west, and from there, 15 degrees towards the south. So it looks something like this. 2.5 newtons, and this is 15 degrees. Okay, I'll zoom in a little bit. All right, so the first thing that we're going to do, I'm just going to clean this up a little bit. The first thing that we're going to do is we're going to draw a table, and in the table we're going to find the x and the y components of each of the vectors. Okay, so we'll start off with a table. Our table is going to have x and y. And on the side, we have two different vectors. We have v1. Sorry, let's see what they were labeled up above. Yeah, v1. And we have v2. Now we need to find the x and the y components of each of those vectors. So let's start with v1. So this one was v1. This one here was v2. So for v1, the x component would be this vector right here, and the y would be this vector right here. Notice that the original vector, that 8 Newton vector, points to the right and upwards. So that's why the x component points to the right and the y component points upwards. So we'll start by looking for the x component, and notice that for the x component, it is the adjacent side. Okay, so if we were to use SOHCAHTOA again, we know the hypotenuse. Now when we do this, we always know the hypotenuse. So really it's a choice between SO and CA. Notice that if you know the adjacent side, you're going to use, or if you're looking for the adjacent side, you're going to use CA. If you're looking for the opposite side, you're going to use SO. Every time we do this, we're going to be looking for both sides. So one time we're going to use SO, the other time we're going to use CA. You just have to know which one's which. So in this case, we're looking for the adjacent side because we're going to start with x. So we're going to use CA. So it would be cos of the angle 25 degrees is equal to adjacent, which is x, over hypotenuse, which is 8.0. When we cross multiply, we can make both sides fractions by making the left side over 1. When we cross multiply, we get x is equal to 8.0 cos 25 degrees. Okay, notice we don't need to go through these steps every single time we do this question. We'll start to see a pattern. Let's look at the previous question. So number 4. Notice when we were looking for the adjacent side, which was x in that case, we did 7 cos 40. Do you see here? 7 cos 40. When we looked for the opposite side, which was y, we did 7 sine 40. Whichever side you're looking for, the first thing you do is figure out whether it's the adjacent or the opposite side. If it's the adjacent side, you're going to use cos, like this one. If it's the opposite side, you're going to use sine. So when you're looking for the adjacent side, it's just going to equal the hypotenuse cos of the angle. And when you're looking for the opposite side, it's going to equal the hypotenuse sine of the angle. So let's take that to the question we're doing right now. When we're looking for the x component, which was the adjacent side, it was just the hypotenuse 8 cos of the angle. When we're looking for the opposite side, y, it's equal to hypotenuse, still 8, now this time sine of the angle. So you don't need to show this work over here anymore. You don't need to do those steps. You can go straight into the final answer. And in fact, the best way to do this is to put your answers right into the table that we made. So for v1, so we're talking about vector 1, okay? So the x component was 8 cos of the angle. Doesn't matter whether you put 8.0 or just 8. And the y component, since it's the opposite, is 8 sine of the angle. Now before you move on to v2, let's just think about whether or not these vectors should be positive or negative. So the x component is pointing to the right, that's positive. The y component is pointing upwards, that's also positive. Okay, so now we can move on to v2. If you think you're ready to do this on your own, go ahead and try it. Otherwise, you can stick with us and we'll do it together. So we have the x component over here and the y component going downwards, like that. So notice that our original vector, 2.5 newtons, was pointing to the left and down. That's why the components, the x component's pointing to the left and the y component is pointing down. Now when we're starting off looking for the x component, think about whether it's the adjacent side or the opposite side. The angle is over here, so the x component is the adjacent side. So we're going to use cos. Okay, so that's this one here. You're looking for the adjacent side, you use cos. If you were looking for the opposite side, you'd use sine. So I'm going to write this as the hypotenuse, which is 2.5 cos of the angle, which was 15 degrees. I apologize, it's a little bit messy here. Now we're going to do the y component, which is the opposite side. It's opposite of 15 degrees. Since it's opposite, we're going to use sine. So we have hypotenuse, which is 2.5 sine of the angle, 15 degrees. Before moving on, though, we need to check if things are positive or negative. The x component is pointing to the left. That makes it negative. And the y component is pointing down. That makes it negative. Okay? So now we know each of our components for v1 and v2. The question is asking us to add them together, v1 plus v2. So adding them together literally means you're going to add the two x components together and then the two y components together. So on my calculator, I'm typing 8 cos 25 minus, or you can write plus negative, but I'm writing minus 2.5 cos 15, and I get 4.8356. Notice I'm leaving lots of extra digits right now, and that's because this isn't going to be my final answer yet. I still have another step to do. Now I'm going to do the same thing in the y direction. So I'm going to add the two components. So I have 8 sine 25 minus 2.5 sine 15. And I get 2.7339. All right, so now I know the x and y components of my resultant, which means when I add those two vectors together, I know the x and y components. So now what I need to do is put those two together. So I have an x component and a y component. I need to put them together to find the resultant, which means the hypotenuse, that's the magnitude, and the direction. So I have an x component of 4.8356. That's positive, so it's going to the right. 4.8356. And then I have a y component of positive 2.7339. I'll label my axes. This is the x-axis. This is the y-axis. In fact, actually, if we go back to our original question, notice that we had north, east, south, west. So I'm going to relabel them as north, east, south, and west. Now my resultant vector always starts from the beginning of the first vector, which is right here, and ends at the end of the last vector. So it goes like this. So this is my resultant. This is my v1 plus v2. So this is what it is that I'm looking for. So to find the magnitude, we use Pythagorean Theorem. To find the direction, we use tan theta equals opposite over adjacent. So let's start with Pythagorean Theorem. So which is a squared plus b squared equals c squared. I'm just going to zoom out so you can see everything. Okay. So let's start to sub in what we know. So my a and my b, it doesn't matter which one's which as long as my c is the hypotenuse. So let's say this is a, this is b, and then this is c. So I have 4.8356 squared plus 2.7339 squared equals c squared. I'll leave this labeled as c instead of writing v1 plus v2 because that'll look a bit messy. So I'm going to solve for c, and it equals plus or minus the square root of all of that, 0.8356 squared plus 2.7339 squared. Now notice each time I've been writing plus or minus, but I've been leaving the answer as just a positive answer. That's just because there's no such thing as a negative length. So every time you do this, it's good form to write plus or minus, but really the answer is positive because you can't have a negative length. So I'm going to type this into my calculator, square root of 4.8356 squared plus 2.7339 squared. And I get 5.55. And the units for that would be newtons, because that was the units that I had in my question. I also need to find the direction. So I'm going to put a little theta in here, and I'm going to say tan theta is equal to opposite over adjacent, and I'll plug in everything that I know. So tan theta is what I'm looking for. Opposite is 2.7339. This was the opposite here because it's opposite of the angle, and this is the adjacent because it's next to the angle but it's not the hypotenuse, over adjacent, which is 4.8356. Now I'll solve for theta, and I have tan inverse of 2.7339 over 4.8356, and that gives me, I'm going to type this on my calculator, tan inverse of 2.7339 divided by 4.8356, and I get 29.48. I'm going to round it to 5 degrees. Whew, I'm almost done. So this is a really long question. So now my final answer is that V1 plus V2 with a vector is equal to 5.55 newtons. And now for the angle. Notice we have northeast, southwest because they were introduced in the question. So we have east 29.5 degrees towards north. Okay, you could have also written it as 29.5 degrees north of east if you like. And that's it. That's the final answer. We found V1 plus V2, so we added up the two vectors. Let's go over all the steps again. We were given V1. We had to find the x and the y components of V1, and then the x and y components of V2. Because we wanted to do V1 plus V2, we added the x components of them, and then we added the y components, and then we put them back together as one vector. So now we drew a vector that's going to the right, 4.8356, because it's an x component and it's positive. And the y component was 2.7339, so that's pointing upwards since that's positive and it's a y component. And then we put them together with a hypotenuse which begins at the first vector and finishes at the end of the last vector. To solve for that hypotenuse, we needed to find both the magnitude and the direction. The magnitude using Pythagorean Theorem, the direction using tan theta. Once we have both of those, we put it all together. The vector V1 plus V2, so adding the two vectors together, I get the hypotenuse, which is 5.55 newtons, that's the magnitude, and then the direction, east 29.5 degrees towards the north. And that's that final answer there. All right, so there's one more question like this. It's quite complicated. There's a lot of steps here. This one actually has 3 vectors that we're going to add to each other. The process is the same, but we're going to have 3 different vectors here with a total at the end. Okay, so if you feel comfortable with this, go ahead and try it on your own. Pause the video and then resume the video when you're ready to check to see if everything's correct. All right, so we're going to begin here by making that table with x and y. So I have x and y, and we're going to label T1, T2, and T3 because that's what it's labeled as in the diagram. T1, T2, and T3. And the question wants us to find the magnitude and direction of the net force. The net force meaning the total of all the forces, which means they want us to add them up again. So this would be T1 plus T2 plus T3. If you don't want to write all of that out, you can also write T net. Okay, so we're going to take each of these vectors and we're going to decompose them into x and y. So T1, it's pointing to the left and upwards. So to decompose it, we would have a vector that points to the left. Call that one x because it runs along the x-axis. And then another vector that points upwards, and we'll call this one y. So we'll start by filling out our table for T1. We're going to start by finding x. Now is x the opposite side or the adjacent side? It's touching the 37-degree angle, so it's the adjacent side. Since it's adjacent, are we going to use sine or cos? I'm just going to write out so, ka, toa. Okay, we know the hypotenuse. It tells us in the question T1 is 7 newtons. That's the hypotenuse. So we know the hypotenuse and we're looking for the adjacent. That means we should be using cos. So to do this in one step, we don't have to rewrite cos of the angle equals adjacent over hypotenuse. The answer is always going to be hypotenuse sine or cos of the angle. In this case, hypotenuse is 7. We're going to choose cos because it's the adjacent side of the angle, which is 37 degrees. Okay. Before moving on, let's check to see, should it be positive or should it be negative? The x component is pointing to the left. That means it should be negative. Let's do the same thing to find the y component. The y component is opposite of the 37-degree angle, so it's going to look similar, but it's going to say sine instead of cos. So it's going to be hypotenuse, 7, sine of the angle. Now let's check, should it be positive or negative? The y component is pointing upwards, so it should be positive. Okay, so we'll do the same thing with T2. In the question, it tells us that T2 is 10 newtons, so that's the hypotenuse is 10. Now we can decompose the vector into x and y. Okay, I made my x point to the right because the original vector points to the right. The original vector also points up, so my y should point up. Let's start with x first. Is x the adjacent side or the opposite side? It's adjacent. It's next to the 53-degree angle. So x is adjacent, which means again we should be using cos. So I'm going to get hypotenuse, which is 10, cos of the angle, which is 53 degrees. It's pointing to the right, so it should be positive. Now let's do y. Okay, so that's why we're in the y column now. Hypotenuse, y is the opposite side, so it should be sine of the angle, 53 degrees. Okay, note that most of the time x is cos and y is sine, but it's not always the case, so be very careful that you're always checking to see whether or not it's the adjacent side. In that case, you're using cos, or if you're looking for the opposite side, you're using sine. Okay, so x is not always going to be cos, y is not always going to be sine. All right, let's move on to T3. T3 points vertically downwards. It's not on an angle at all. So that means it doesn't have an x component. It's not on any sort of angle going to the left or right at all. So its x component is 0. And the y component, they tell us in the question, T3 is 13 newtons. So the y component is just 13. But since it points down, it's negative 13. Okay, so on the side, let's do some other examples that are like T3. Let's say we have a vector like this, that's 5 newtons. What's the x and what's the y? The x component would be 5 because it points positive, points to the right, so that's positive, and it doesn't go up or down at all. The y component then would be 0. What if we had a vector like this? X and y. The x component would be 0 because it doesn't point to the left or the right at all. And the y component would be positive 7. Okay, what if we had a vector like this? The x component, it's pointing to the left, 9 newtons, so the x component would be negative 9, and the y component would be 0. Okay, so if a vector is pointing only vertically or horizontally, it will just have an x or a y component. The other component would be 0. So now we're going to add all of these vectors together, all of these components, so that we can find the x component for the net force and the y component for the net force. So on my calculator, I'm going to start with the x column. I'm going to type -7 cos 37 plus 10 cos 53, and then I can add 0, but that doesn't do anything, equals, and I get 0.4277. Now I'll do that in the y direction. 7 sine 37 plus 10 sine 53, and then minus 13. And I get -0.8009. Alright, so now what I can do is I can take these x and y components and use them to find the magnitude and the direction of the net force. So I'm going to draw what this looks like. I have a vector that has an x component that's positive 0.4277. So it's a positive x component, so that means it will be pointing to the right. 0.4277. It also has a y component that's negative. That means it points downwards. 0.8009. I can put the negative here if I want, but the fact that I made the arrow point downwards implies that it's negative, so I don't really need it. Now I'm going to draw the resultant. The resultant always begins at the beginning of the first vector, so right here, and ends at the end of the last vector. So it goes like this. So this one I'm going to call T net. Okay, so if I'm looking for T net, now this is 90-degree angle because we have x component, y component, those are perpendicular to each other. If I'm looking for T net, that's just using Pythagorean theorem. So I have a squared plus b squared equals c squared. My a is 0.4277. My b is 0.8009. And my c I've called T net. I'm going to solve for T net, which means I'm going to plus or minus square root 0.4277 squared plus 0.8009 squared. And now I'm going to type all of this into my calculator. So I have the square root of 0.4277 squared plus 0.8009 squared, and I get 0.90. I'm going to round it was 0.9079. I'm going to round the 7 up to an 8. My units, if I look at the question, were newtons. And I'm ignoring the minus sign because a force, I'm going to put it as positive and then I'll give it direction later. Okay, so right now I'm just finding the length of the hypotenuse. The question wanted the magnitude, so that was the magnitude right there. I also want the direction. So for the direction, I'm going to have to find this angle right here. Always finding the angle from the beginning of the resultant vector. So I'm going to use tan theta. So I have tan of my angle, theta is what I'm looking for, equals opposite. This is my opposite side. 0.8009 over my adjacent side, 0.4277. Solve for theta using the tan inverse. Now I'm going to type this onto my calculator. So I have tan inverse of 0.8009 divided by 0.4277, and I get 61.9 degrees. Okay, so finally I can write my final answer, which is that the net force as a vector, meaning I'm going to include both my magnitude and my direction, is 0.908 newtons. That's my magnitude. And my direction, let's look at the original question. The original question just gave us an x and a y axis. It didn't give us northeast, southwest. Okay, so here, I'll just draw in my x and my y axis here. This would be my x-axis. This would be my y-axis. Okay, so this is the direction we're looking for here, the direction of this net force, the T net, T for tension, which is a type of force. So my T net is equal to 0.908 newtons. And now because I can't say northeast, southwest, I have to say the angle, which was 61.9 degrees. Now, is this above or below an axis? It's below. And which axis is it below? It's the positive x-axis. All right, so that was question 6. Really long questions here. These are the types of questions you'll see on your tests. Okay? So I hope that helped. Thanks so much for watching, and see you next time.